Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hi guys, welcome to a brand new episode of the Clear to Send podcast. And today we're going to talk about 802.11 power saving and how it works with between the Wi-Fi client stations and the AP. I'm here with Roel. Hey Roel, how are you?
Hello, good morning.
Morning. Right before the election for you, right?
Right before the election, right after Halloween. So I was actually out. I guess it's not really trick-or-treating because there really wasn't any trick-or-treating, but came back and then I was like, oh, gotta record tomorrow morning.
Yeah, we did some stuff with the kids here yesterday, dressed up, and then instead of doing what they did in the neighborhood here, instead of doing trick-or-treating, is like, people kind of know where the kids are, so they would prepare like little candy boxes and then they would just go and deliver them to the neighbors. So it was kind of a nice way to do it as well.
I went to an area where they did socially distance trick-or-treating, and this neighborhood, they must have gotten together to figure out a way to do it, but a lot of them were using pipes to just slide the candy down, and the kids just put their bags underneath it. And then like it was really interesting how it was done. I was like, oh, this is kind of cool. It's different. So they call it a shoot. So they'll like count down and then shoot it down, and at the end of the pipe there's like a little pumpkin face and the candy comes out of the mouth. Pretty neat.
That's amazing.
Yeah, it was good for the kids.
I was going to say the human is always good to finding good and other solutions.
There wasn't too many houses participating. So once you were there, the parents would always, whoever's handing out candy would always just say, take more, like take a bunch of candy instead of just take one,
Yeah. Oh, anyway, so you did some work related to power saving this week, and then you talked to me about it, and then I guess you sparked my interest. I went back to the standards and did some PCAPs and stuff. So this morning, we kind of wanted to talk about, how client stations do it nowadays and what we found in our testing, and kind of talk about the theory a little bit behind it. So you guys kind of have an idea of what it is and then how it works in practice.
Yeah, kind of had to revive what we knew a long time ago. And it's been a long time since I looked at power saving and had to learn about it. But this past week had me re-looking at, or even reminding me how devices are so different from each other and how they interact over the Wi-Fi network. And so in my scenario, which prompted me to talk to you about it, was a scanner in a warehouse, and whether it's power saving mode and how it communicates with the AP affects how reliable the connection is, especially when roaming and whatnot. So part of it was troubleshooting to try to determine whether there was an issue, right? So right now I still don't think there is an issue, but I can talk about where the theory is going after we talk about power saving.
Yeah, and power saving, when I don't know about you, but when I was studying CWNP, certifications, I found it to be like a more advanced and obscure and complicated thing, right?
It's a complicated subject. It is.
Yeah, so I guess what we could try to do here in this episode is try to simplify it a little bit and explain what it is, because I think it can be simplified, and especially for the way we use it.
It's very much an interpretation, right? So we have to read what the standards say about power saving and then take a look at how a device is using power saving, because it very well could be interpreted differently by whoever is developing the drivers for these clients.
Yes. So the core, I guess, basic principle is a client station can have two different states. They could be either awake. So when the station is awake, it means that it's actually fully powered and able to fully
actively
transmit and
receiving or
receive.
transmitting. Yeah.
Yes. So that's the first state. And the second state is what they call the doze state, or we usually call it the sleeping state.
Sleep. Yeah.
And this is when the station is not able to transmit or receive and is consuming lower power as a result. So I guess the purpose for a client station to go into the doze state is to kind of switch off its Wi-Fi transmission capabilities, so it can actually save some battery life.
Yeah. Hence power saving. Power management is what we're talking about in the 802.11 standards. So what we can do in the show notes is include the sections in the standards. So you could take a look at this yourself and be able to maybe follow along and understand what we're referencing, because that is our reference, is the standard and how that looks, right? So I think this is episode 243, Francois.
244, maybe, I don't know. I put 244, but maybe you're right.
I'm pretty sure it's 243.
243, all right.
Because we recorded an episode yesterday, but it actually has to be played in the future. That was 243, so we have to switch it around. But
all right.
We're going to talk about power management. This is power save, so hence the awake mode and the dozing or sleep state for a client. And we talk about sleep state and what setting a device would go on. It doesn't really actually sleep for a very long amount of time, right? It's not like it's sleeping for seconds or even minutes. And there's even that enhancement in 11AX, which is the target wake time, which I think just kind of takes it a whole other level, which we do have an episode on that. This one is specifically about power management, power saving, and a lot of these older devices too will utilize that. Even newer devices today, you were testing this with your iPad, Francois, and I was testing it with my iPhone. They do use the power save method.
Yes, and I guess what we're talking about here, everything that's defined in the standards. So, you have those two states, the awake and the dozing state, and then the standards just define the rules of, how, pretty much the protocol of what frames needs to be changed between the client and the AP to kind of notify that, we're changing state. And I guess that's all we're talking about today, right? If you just simplify it, we're just talking about the different states that exist, the awake and the doze state, and then we're talking about the protocol defined in the standards for a specific station to notify the AP that it's changing state, and then based on that, the AP will know if it can just send the frames that are arriving for that specific client, or if it needs to kind of buffer the frames and wait for the client to wake up.
Yeah. And so when in my environment that I was troubleshooting, there are these older Zebra scanners. They're 802.11n, and there is actually a setting in a wireless setting in the scanner where you could change the battery usage mode. And so the battery usage mode actually relates to power saving, right? Because you want people, or they call them pickers, will use them to scan. They're on the floor plan, kind of looking for inventory and tagging them. So we're not tagging them, but scanning them and taking them. And you don't want the battery to die anytime soon. So there's three different battery usage modes that I saw. One of them was a max power save, a fast power save, and one called CAM, which I think stands for constant active mode, which means it probably doesn't utilize power saving that much. That's the one with the least battery, has the most battery consumption, right? So in my troubleshooting, I was just looking at fast power save, and I kind of wish I was looking at the other two modes to get a difference for what that looked like. But it very well touches upon power saving and power management because it was a Wi-Fi setting. And so we have to look at what that means for a device. And we don't have that for every devices, right? There isn't maybe that's the low battery usage, Francois, like on an iOS device, how you could try to save low power mode. That could be part of it as well.
Yeah, I think a lot with iOS, I think a lot of those stuff are like automated and based on the device. So when I actually did my capture, I was trying to see, okay, what's the difference if I have my iPad plugged in into the power versus having my iPad not plugged in into the power, you know?
Yeah.
I did those type of tests. What you could also do is put your device in power saving mode and see how it impacts the Wi-Fi connection. I know for iOS, for instance, it would like drop a number of spatial streams if you have devices that are compatible with multiple spatial streams, right? So it might also affect the threshold that they have for the power saving.
Yeah.
I haven't tested that though.
Yeah, so we still have a lot more tests to do, right? So the tests that I have done have been very limited to a specific scenario and not compared to other scenarios. And it's the same for you, Francois, because you didn't have as much time as I did, but you still were able to do quite a few testing. But maybe that's something we could discuss even in a future episode, looking into more detail of power save, because this is kind of like the beginning of touching upon power save, because we kind of wanted to get into the frames a little bit so you understand where to look for this. So in the show notes, we're going to include Wireshark filters as well. And we may also include some PCAPs just for you to look at. There is a power management flag that you could see in Wireshark to determine whether or not a client is in an active state or a doze state.
Yeah, and I think what's important to mention at this point is that the power management bit or flag is part of the MAC header, so it's pretty much there in any Wi-Fi frame that is sent, whether it's management frame, a control frame, a data frame. You're always going to have this, this power management bit, which is inside the frame control field of the MAC header.
Yeah, so it's a easy one to filter out. And what I've done with looking at power management is I created a column in Wireshark and used that Wireshark filter to really see quickly which frames are where the station will stay up and which one will the station go to sleep. And so that's how I was trying to analyze some of the behavior of a client on the wireless network. And you will see that some clients are very different from others. But let's keep talking about the frames itself and what the standard says about power management.
Yeah, so this the power management bit can either be 0 or 1, right? Because it's just one bit, it's one flag. And so what's going to happen is whenever a client stations want to notify the AP that it wants to go to sleep, right, that it wants to move from the awake state to the doze state, it will send a frame and then change that flag to 1 and notify the AP that, hey, by the way, I want to go to sleep, I'm going to sleep. Yes, right? Yeah. So it will send a frame that will change that specific flag to 1, and the AP will know that that station is going to sleep.
Yeah, and that is set in a null data frame from the device. It's a data frame, and from my point of view, I see it as a subtype 4, which, Francois, you've seen it. What that means is it's a data CF pole frame, right?
Yeah, so in order for the client to be able to specify to the AP that it's going to sleep, it has to modify that bit. And what they do is instead of sending like any type of frame, they send that null data frame of subtype 4 and in the header. So that frame doesn't have any data.
Yeah, there's
the purpose of that frame is just to send that specific bit and let the AP know that it's changing a state. So it doesn't really have any data. And then, yeah, from what I've seen, the subtype, so the type of frame is 2, so it's a data frame, and the subtype is 4, and the subtype 4 is the like you said, it's the data CF pole.
Yeah, there's no data at all. It really just says power management. I'm gonna stay up or go to sleep, one of those two modes, and maybe there is some additional functionality to this, which we haven't really looked too far into yet. We're just looking at just power management for now.
And also, I think, I think it's we should mention that frame is unicast sent from the client station to the AP, and therefore, because it's the unicast, the AP will send back an acknowledgement. So you should be able to see, the null frame sent for the clients to advertise its changing of state, and then the AP should be sending back an acknowledgement frame.
Exactly. So if the AP does not acknowledge it, there will be some retries, right? So I have seen my device try to tell the AP what state it's going to go in, but it doesn't get acknowledged. So it'll retry and resend that null data frame until the AP acknowledges it.
Yeah, so that's what's happening when a client station wants to go to sleep. So now what's happening when a client station, needs to wake up to receive data? Like, how does that work?
Yeah, because if it's in a doze state, then that means the AP is not going to send any traffic to it, right? So what if the client has traffic?
Yeah, so if there's traffic, designated to the client, the AP will kind of buffer that data. And then the AP, there's a mechanism that the AP used to kind of advertise the client that there's buffered traffic available, and this is what we call the DTeam.
Yeah, there's DTeam, the traffic indication map, and the delivery traffic indication map. So this is all part of the wireless network management portion, because it has to manage that communication and tell the client, basically tell the client when to wake up, right? It's kind of an interval. It says, hey, wake up at this interval so I will let you know if you have buffered traffic.
Yeah, exactly. That's exactly the principle. So, you guys know that, the AP will send a beacon frame. It's usually every 102.4 milliseconds advertising the different SSIDs, one beacon frame per SSID. And so what the AP will also set is, for specific beacon frames, it will send that traffic indication map indicating, the dosing station if they have traffic buffered for them, right? They don't include that traffic indication map in every beacon. You have another interval that specifies how often it will send that traffic indication map. So that's what we call the DTeam. So if the DTeam is set to 2, every other beacon will have that traffic indication map information. And so the client station that are dosing, what they would do is they will wake up for every other beacon to kind of listen for the beacon, and then try to see if there's anything for them. And if there's nothing for them, they can go back or stay in the dosing mode.
So when a client wakes up at this interval, how does it know that it has traffic, right? So you look at this TIM, this traffic indication map in the beacon frame, and there are going to be some fields. If you expand that, that there's going to be a virtual bitmap field, which would say, hey, I do have buffered traffic. And then associated with that is an association ID for the client. And that's telling, hey, this client, once the client wakes up, it will look at that and go, oh, I have data. Like it's awake now, it has buffered data. And then the AP would send it, because then the client will have sent a null data frame saying I am awake, right?
Exactly. So whenever Wi-Fi clients associate to an access point, a part of the association process, the AP will, when it actually accept the association, when it sends this association response, it will provide, it will reserve an ID that we call the association ID, the AID, for that specific clients, and it will send that information to the client. So the client will know its own association ID. The AP obviously knows, the association ID and the MAC address of the client, and it keeps like a nice table of, MAC address versus association ID on its end. So whenever there is a frame going for that specific client, it will just know, the MAC address and the AID, and like you said, it will specify in that specific field that there is buffer traffic for that AID. So when the client wakes up to listen to the beacon, it will see that there's traffic for itself, and what will it do? Interesting question. What will the client do to retrieve the buffer traffic?
Yeah, so it has to tell the AP, hey, send these buffered frames. And Francois, this is where I have the challenge, because I don't think I even have a capture to show this. But in the standard, there is a PS poll frame that is going to be sent from the client to the AP asking for the buffered frames.
Yeah, so in the standard, when you read the sections on power saving, they tell you that the clients will, when it wakes up and it sees that there is some buffer traffic for itself, it will be sending a PS pool frame to request the buffer traffic. And the PS pool frame is an acknowledgement, is a control frame. So it's type 1. And it's a specific, control frame that was created exactly for that purpose. But that's more, I guess, how legacy power saving works. If you look at what we've seen in our packet capture with more recent client stations, what the client station will do is they will send that null data frame again. So they will use the same null data frame, so type number 2 and subtype number 4, and then in that null frame they will specify the power management field to 0, pretty much telling the AP that, hey, now I'm awake, right? So they're using that same null frame, but they changed the bit to 0, telling the AP that I'm now awake, you can send me those buffer traffic.
Yeah, and for me it's been pretty difficult to even try to map each conversation out, right? I look at the frame, I go, all right, I got a null data frame here. It says it's waking up. I see the beacon frame where the AP says I have data, buffered data. And so you have to try to track each one of those and try to piece it together. And I find that could be the hardest part, is making sure you have the right frames. And that's where I guess things start to become a little bit different from what we read in the standard, right? Because then that's when different devices act very differently with power save.
Yeah, and I guess what I've done to kind of make sure I'm looking at the proper frames is I've used different filters, and we'll put them in the show notes if you guys want to use them in Wireshark. But the first thing I do is, just like you, I add the columns for the power management bit. And the nice thing about that in Wireshark is that instead of showing you, the bit value 0, 1, it will tell you the station will go to sleep or station stay up. So you have like a little sentence in English, which is nice. And then what you could do is you could filter for any beacon frame that has a virtual bitmap, which means that there's buffer traffic pretty much.
Yeah.
So that's what I do. So I list all the beacon frame that have a partial virtual bitmap, and also add that partial virtual bitmap to my column so I can see them. And then I would select one, and then I would remove my filter, and then I would try to see at which frames I'm getting. And you should see right after that, what I've seen anywhere in my testing is right after that beacon frame that's specifying that specific client has traffic bufferized, then you should see that client sending that null data frame, telling the AP that it's waking up. And then you should see the AP answering with an acknowledgement. And then you should see the client sending a RTS, the AP sending a CTS, and then the client receiving that data.
Yeah, and so, also part of that I try to do is find the association ID of the client. So you may if you're doing a capture, you may have to restart that association process to get that association ID, so you can tie that even to the client that you're specifically looking at.
Oh, that's actually best practice, Roel.
Yeah.
For me anyway, that I'm trying to implement now. Whenever I do packet capture, I always disconnect, reconnect my client.
Yeah, just in case you're trying to troubleshoot, you gotta get that because I was in the environment and I see a bunch of clients. I had one AP with 40 clients on it. I'm like, which one is mine? So I capture the authentication process, and you'll see it in the response from the AP with the association ID, and so you could add that to your filter as well if you've got a capture with many clients on there.
And then part of also the beauty of capturing the association process is you get a little bit more than just the ID. You also get the client capabilities, and you could use that when you do your troubleshooting. If you see different frame exchange, you're like, hey, it's weird. Why do I see this? And then you could go back to the association. It's like, oh yeah, the client supports 11K, or client supports multi-user MIMO. That's why I see this.
Yeah, exactly. So like I'm even doing it as we speak, trying to filter everything. But I see my client stuff on there because the association ID is a slightly different format from what you see in the association response.
Yes.
But what's interesting is the traffic indication map. If it has some for multiple stations, it'll list all the association IDs in there. It'll have in the beacon and a list of them, one in each, basically its own row, and an association ID. We can add a screenshot showing that because in our tests, if we're testing one device, we've got just one association ID in there. But it's nice to see how you could filter this and see then all the different communications from each client to try to see if you've got the same behavior between each of them.
Yeah. So also, what will show is those different frame exchange, the beacon, and then the null frame sent by the client, and the AP acknowledge it, and then after that, the the AP will send the RTS CTS, and then the AP will send the traffic. So we'll send that so you guys can have that. Also, some interesting finding that we found, I guess, is, and Roald, you were talking about that earlier a little bit, but different client devices will have different implementations sometimes of that process. And when I did test it with my iPad, and I checked, and I'm actually running version 13.7. So okay. I didn't upgrade for 14 yet. So I'm using 13.7, and I could see that whenever the iPad is going to sleep, but whenever it's waking up, instead of sending that null data frame once, it sent it twice. So every time. So I could see two, two going away, two staying up, two going to sleep, two staying up every time. So, and both times they are acknowledged by the AP. Okay, so it's not like it's a retry. It's just like...
Yeah, because I was asking you that. I was like, one of them a retry frame?
Yeah, no, it's not. So it's just like, I don't know, it's like maybe a safe mechanism to make sure that it works. But yeah, I could see that. And on your end, when you tested with the scanner, it was just one time, right?
Yeah, I didn't see it sending. I didn't see the scanner, and the scanner is 802.11n, and it's pretty old device in my opinion, but it did not send it back to back, right? There's no doesn't send it twice out about staying up or going to sleep. And then I excuse me, I even we were talking about, hey, it's iOS, maybe it's the same across all iOS. So I was looking at my iPhone, but I don't see the same thing with my iPhone. So you have an iPad, I have an iPhone, and when I looked at my capture, I did not see it sending out a null data frame twice. So it's interesting how there would be a difference between an iPad and an iPhone, but the other difference is I'm on 14.1, so I don't know if there's even a change in how that's done in iOS. That very well could be, but we'd have to do more testing to really identify that behavior.
Yeah, and then maybe, I don't know if it's related to that, maybe the iPad is plugged into the power and not plugged in.
Yeah, because power will, I guess it depends on the vendor, but a lot of times we have seen how much power is being available on the device will affect how it talks on the Wi-Fi network. So if it's running out of power's low, then it will start trying to conserve power. So maybe then, and I'm just saying this off the top of my head, maybe then the power save mode is a lot more aggressive, right? And remember, I was talking about the scanner and how there's 3 different modes on it. A device could be configured to go into a more of a max save power mode in order to conserve battery. Or maybe if you've got full battery, it doesn't go into power save mode as often, right? So it just depends on the device, and you'd have to profile it to really understand how it works.
And also, I think what's interesting when you do those testing on your end is try to look at the delta time column in Wireshark, so you can understand for how long the clients are, going to sleep for. And I mean, in my testing, what I can see is it's like tens of milliseconds. The maximum I could see was like 100 milliseconds, I think. It was more around like 60, 70, 80 milliseconds. Sometimes it would go asleep for like 15 milliseconds. So that's what we're talking about. We're talking about more like tens of milliseconds, max hundreds of milliseconds. And that could depend on the device as well, right? But when I did the test with my iPad, that's what I could see.
Yeah, very, very much still depends on the device. So in my scenario, what I was really looking for was whether or not the power save mechanism affects how the application on the device is being used. So the users would complain about getting disconnected, and that's another issue as to what kind of disconnection is that. But what I wanted to test was, all right, I have a user with a scanner going in between aisles. If he scans and that data is transmitted and received, then the device does not have anything else to do. So it'll go into a power save mode. Now, during that time, the person's also walking and going to another aisle. And depending on how the APs are deployed, they were deployed to provide signal down each aisle. So if the device went into a doze state and the user then walks into a different aisle, it might not be the very next aisle, but maybe a few aisles over, it does not, I don't know if it will provide enough time for the device to wake up and then perform some sort of reassociation, or does it wake up during that walking process of the user and try to send a null data frame saying I'm awake, but maybe that AP does not hear that frame anymore. So it keeps retrying to send it, and then it'll stop resending and then try to find another AP to connect to. And so that there's time that gets eaten up with the device trying to send data, find a new AP, associate to the new AP. And all I know is that the application sends heartbeats back to a server. And so if the threshold is met during that time, it could form a disconnect. And that's a quote unquote disconnect to the user, because it would kick them out from whatever screen they were on. So that's what I was trying to figure out. And I guess the easy way to really try to, I guess, quote unquote, fix that issue. It's not a big issue. It's just there's been improvements. So we want to see if we can improve even more. We could set some devices to constant active mode and see if there is a change in the number of disconnects.
So are you going to go back and do more testing, or what's the deal with this customer?
I mean, they document the issue. So typically users will go to somebody and tell them they had an issue, and they actually have a running list of like what time was the issue, where they had the issue. And so I could make a recommendation to just put it into constant active mode and have them track that device or that person and see if they have issues. And if they tend to go away, then maybe that is part of it, because it's just a different way that the aisles were set up for Wi-Fi. And I think roaming is also part of the the challenge is we walk pretty fast, or some people walk pretty fast. Can the client keep up on finding the next AP, joining it? Because someone can very well just walk into an aisle, scan one thing, and then leave. Right? It's not. They don't tend to hang out in that area for a very long time. So it's also very much how the workflow is, and also things like pick paths. And you have to understand how people are walking throughout a warehouse. And sometimes I have to talk to the people who made the application and understanding how they made it, because I had a conversation with someone who did the configuration, and I found it very insightful because in this warehouse, it's a retail warehouse. So people are scanning inventory, putting it into a bin, and then they got to go get the next piece of inventory. So the application tells them where to go. And they told me they try to get it, and the software is configured to provide a pick path to a user. So they're not jumping from, say, aisle 1 to aisle 40 and then back to aisle 2 kind of thing, right? Because that's kind of inefficient, having to walk all the way on the other side of the warehouse and then back to the other side. So they almost have them going into like a zigzag motion, just depending on, it might not be every aisle, but it's like every few aisles, and they make their way towards the end. And so that I thought was kind of interesting in me helping to understand pick path, because you could potentially survey the same types of pick paths, right? And then you can get a better a little bit more accurate roaming. In terms of roaming. And so that I thought was very helpful. And I know that's not necessarily a part of the Wi-Fi process, but I like to understand how people use it down to how they walk in the environment in order to tie that back to what we see on Wi-Fi.
Yeah, I think that's an important part of the defined stage of the design, and in some environment is very critical. I remember working for this conference, and they were talking about the fact that they would only, on the first day of the conference, they would only open the doors at one specific times, and they had different set of doors that they would open at different times in order to kind of filter the people and do the security check and all of that. And then between two checkpoints, they were telling us that they wanted people to download the application for the conference, especially on the first day. So that was good information for us to know, because first we would know the flow of people, and also we'll know the density, right? We knew that we might have like 100 of people, in one spot in the conference center that will try to download, a few megs application all at the same time, right? So it's important to know this information, so in your design you can take that into account and make sure that it's going to work well.
Yeah, exactly. And so mobility is very big today. And so I think having to understand that, and not just sprinkle APs where you think coverage is needed. A lot of it today is understanding where people are going to be, where's the start path, where do they walk, and facilitate, so you can help facilitate roaming more efficiently. Even if you are just using omnidirectional APs, you still have to consider that as part of fixing sticky client issues, right? That still happens a lot. I still run into environments where their complaint is it's slow, and then so I start asking, when is it slow? When do you find that your Wi-Fi is slow? And they say, well, whenever I walk from my desk to the conference room, the connection isn't very good. And then that's when you determine that, you're still on the same AP you were connected to at your desk, but you're not connected to the one in the conference room. And so that's when you start tuning things like transmit power, or maybe moving APs to better facilitate that roaming process. But that's where it starts to get a little bit more complex with Wi-Fi, I think. And then you have to understand how these devices work over Wi-Fi. There's a lot to consider, especially if you run into an environment where you've never seen that device before, right? So now you have to spend time getting to know it. It's like you gotta talk to this device and say, tell me more about yourself and how you like. I like long walks on the Wi-Fi network down the
Do you know if they were using DFS channels
Yes,
in that environment?
So that's the other consideration we have to make too.
Yeah, because it can increase the roaming delays as well.
Yeah, and this application is kind of a like real-time application, right? It has to go talk back to a server that tells them where to go next, and then there's that part, and then there's the inventory part where it has to query the server in real time, like what's the inventory or where to put things. So there's a lot to it, right? I'm only looking at one piece of this the whole operations.
Right. Well, I think we pretty much gave a nice introduction to the subject, maybe more than an introduction.
Yeah.
Right?
Yeah, more than an introduction. Started talking about why we actually started looking into this, and maybe it starts triggering something in your mind, and maybe we're missing something. So I would encourage you guys to leave a comment on the show notes page, go over to Clear to Send and check out the power saving episode. Or if you haven't already, join us in the Clear to Send Slack. You can go to cleartosend.net/join-slack and join us there for a conversation. We just had a lot of new people just join on Halloween, which is interesting.
Yeah.
I imagine like other countries probably don't celebrate Halloween, and some countries celebrate it differently than United States. So come in and talk to us there about it. And we'll have some great conversations there on Slack. It's really fun and interesting to see people from around the world and how they do Wi-Fi, right?
Yes. And then also I think it's a good opportunity to remind everyone that we do have show notes for every episode we produce. So if you go to cleartosend.net/ in this case 243, then you'll be able to see the pictures, the PCAPs and the details and the snippet from the standards where you see the structure of the frames and all of that. So if you're interested in actually visualizing what we're talking about, feel free to go to the show notes and take a look over there. We do spend some time working on those.
All right. So what do you have going on this week, Francois?
I'm actually teaching for France Ekahau class.
Oh, very nice. Very cool.
Yeah. Last week I was teaching a MIS class. So it's a lot of teaching right now, but it's awesome. I'm getting a lot of interesting students that, I see that people are more and more interested in Wi-Fi, definitely.
Yeah, for sure. I find that this time, the current state we're in, Wi-Fi is a little more critical nowadays.
Yes,
especially in different industries. But for me, like I'm doing more reports. I got to finish up this last report, which is associated to this power save. And power saving may not even be an issue in this case. I just have to analyze the frames, but still working on Wi-Fi. Just like
that's good. I'm also doing a little bit of programming lately.
You've been showing me.
I've been in trying to. I know you've been talking to me about trying to create UIs for my script for a little bit. So I finally
trying to encourage you to move forward.
Yeah. So I've been this week I've been working on trying to figure out a way to create UI for some of my Python scripts. So I'm actually, in order to learn it, I'm actually working on a program that's not very technical. It's more like something I use for my business. But it gives me a chance to just play around with the UI stuff.
It's a template for what you could do with your technical scripts.
Yeah, and maybe later on I can reuse some of that to create simple UIs for some of the scripts I create. So anyway, it's been a good learning curve, and sometimes I get stuck on UI stuff like front end stuff for hours because I want everything to align properly, and I get lost in the CSS.
You get stuck on that perfection, right? You want it to look good.
Yeah, exactly. That sometimes I get lost on that. So I kind of alternate in between the front end and the back end whenever I get bored.
Well, it changes your mind a little, right? So you work on the other creative side of the brain.
Exactly. Sometimes you know what, I'm not going to fix this tonight. Let me work on the back end on the database and stuff. And then, Anyway, it's been fun.
Awesome. So hopefully you'll be able to share some of that once you get get more comfortable. But we want to thank you guys for listening to this episode. If you have more to share, let us know in Slack or on Twitter or even on the show notes page. We have a comment section. But other than that, we will see you guys on the next episode. Bye, guys.
Thank you, guys. Have a good week. Bye-bye.